Right now, you're probably not thinking about the fact that you're a walking calorie surplus. Your brain is burning through roughly 20% of your body's total energy just to keep itself running, and it's doing that while you sit still, scroll, and barely notice. No other animal spends that kind of energy budget on thinking. Not close. And for most of human history, nobody could explain where that extra energy was coming from. You probably assumed cooking started because raw meat tasted bad, or because fire kept early humans warm, except neither of those is the real reason our ancestors started putting food over flame. And when you find out what cooking actually did to the human body and the human group, it changes how you think about dinner, about family, about why you're even capable of reading this sentence right now. Let's start with the timeline, because the timeline is the problem. Around 2 million years ago, a hominin species called Homo habilis had a brain roughly the size of a chimpanzee's. Then, somewhere between 1.9 and 1.8 million years ago, something happened. Homo erectus shows up in the fossil record, with a brain that's ballooned by roughly 40%, smaller teeth, a shorter gut, a body built less for climbing trees and more for walking long distances on open ground. That's not gradual drift, that's one of the fastest anatomical shifts in our entire evolutionary history, and for decades nobody could agree on what caused it.
The obvious answer people reach for is meat. Early humans started hunting, started eating more animal protein, and protein fueled bigger brains. That's part of the story, but it doesn't hold up by itself. Chimpanzees eat meat too, sometimes hunting monkeys in coordinated groups, and their brains never made this leap. Something else was happening on top of the diet shift. In 1995, two researchers named Leslie Aiello and Peter Wheeler proposed something now called the expensive tissue hypothesis. Their idea was simple. Brain tissue and gut tissue are both metabolically expensive. Your body can't easily afford to run both at full size at the same time. So if brain size goes up, something else has to shrink to pay for it. And when they looked at the fossil evidence, they found exactly that trade-off. As hominin brains got bigger, guts got smaller. But a smaller gut can only process food that's already easy to digest, which raises an obvious question. What changed about the food? This is where Harvard primatologist Richard Wrangham enters the story. In his 2009 book, Catching Fire, Wrangham argued that the missing variable was cooking, not meat, not tools, cooking. Heat breaks down tough plant fibers and connective tissue in meat before your body has to. It essentially outsources a chunk of digestion to the fire instead of the stomach. A cooked meal delivers dramatically more usable calories than the same food eaten raw, even though the calorie count on paper looks identical. Your gut has to do less work, which means your body can afford to shrink it. And that freed up energy had somewhere to go, straight to the brain. Here's where it gets complicated though, and where a lot of other explainers stop short. The problem with Wrangham's theory isn't the biology, it's the archaeology. If cooking triggered this brain explosion 1.8 million years ago, there should be fire evidence from that period. There isn't. Solid, undisputed evidence of controlled fire doesn't reliably show up in the archaeological record until around 800,000 years ago, some sites pushing closer to 1 million. That leaves a gap of nearly 1 million years between the anatomical evidence, which says cooking should have started, and the physical evidence, which says fire wasn't confirmed yet. Wrangham's answer to this gap is that fire leaves almost nothing behind. A small, temporary cooking fire built by nomadic foragers, used for one meal and never rebuilt in the same spot, wouldn't leave the kind of thick ash layer archaeologists can detect 1 million years later. Modern hunter-gatherer groups build fires exactly like this today, and those fires vanish from the landscape within a few seasons.
So the absence of evidence, in this case, might not be evidence of absence. It might just mean fire was too small and too temporary to survive that long. But even if cooking explains the brain, it doesn't fully explain what happened next, because cooking didn't just change digestion, it changed something about how humans had to live together, and that part is stranger than the biology. Raw food in the wild is eaten roughly where you find it. You pick a fruit off a branch and eat it standing there. Nobody has to wait. Nobody has to share the moment. Cooking breaks that pattern completely. Cooking takes time. It requires someone to gather fuel, tend a fire, and stay near it while the food transforms from inedible to edible. During that window, the food is vulnerable. So is the person cooking it. A cooked meal sitting over a fire is an easy target for theft, especially from bigger, stronger members of the group, which means cooking only works as a strategy if there's some kind of social agreement in place, an unspoken contract that says this food belongs to the person who prepared it, and everyone else waits their turn. That contract doesn't exist anywhere else in the animal kingdom in this form. Chimpanzees will steal food from each other constantly, especially from smaller or weaker individuals. There's no concept of, this is mine because I made it, and you'll get yours later. Cooking forced early humans to build exactly that concept from scratch, because the alternative was chaos. Every fire would turn into a fight. And once that trust structure existed, it didn't stop at food. Wrangham has argued that cooking likely reshaped the relationship between men and women specifically. Because cooking takes time away from foraging, someone in the group had to gather food while someone else prepared it, which meant labor started splitting in a new way. And because a prepared meal sitting by a fire is valuable and vulnerable, someone had to guard it, which meant pairing off, protecting a partner's food supply, became a survival strategy in itself. Some researchers even connect this to the origins of pair bonding in early humans. The idea that a stable partnership wasn't just about reproduction, it was about making sure nobody stole your dinner while you were out getting more of it. Then there's the meal itself, the actual act of sitting down together. Once food had to be prepared instead of eaten on the spot, waiting became necessary. And waiting, as a group, around a shared fire, created something raw foraging never could. A daily gathering point. A moment where the entire group was in the same place at the same time, not scattered across the landscape chasing individual calories. Anthropologists studying modern hunter-gatherer societies still see this today. The evening meal isn't just refueling. It's when stories get told, plans get made, disputes get settled, and social bonds get reinforced. Some researchers argue this nightly gathering around a fire may be one of the earliest consistent social structures our species ever built, older than language as we know it, older than settled communities, predating almost every other institution humans eventually invented. So here's the fuller picture. Cooking gave the body permission to grow a bigger brain by making digestion cheaper. But cooking also gave the group permission to become something more complex than a loose cluster of individuals competing for the same berries. It demanded trust. It demanded a division of labor. It demanded patience, a willingness to wait for a meal instead of grabbing whatever was closest. Every one of those demands pushed early humans toward exactly the kind of social cooperation that a bigger brain is actually useful for. The brain grew because cooking freed up the calories, and the brain had something to do with those calories because cooking simultaneously forced humans into a more social, more cooperative, more trust-dependent way of living. That's the part most people miss when they hear cooking made us human. It's not just that cooking changed food, it's that fire changed what it meant to eat with someone else. The shared table, the family dinner, the unspoken rule that you don't take food off someone else's plate, all of that traces back to a fire on the savannah and the vulnerability of a meal that wasn't ready yet. Tonight, when you sit down to eat, you probably won't think about any of this. You'll eat because you're hungry, maybe with people you care about, maybe alone in front of a screen. But the fact that you're sitting down at all, waiting for food instead of grabbing it and running, is a habit almost 2 million years in the making. Your brain got big enough to write this sentence because somewhere, a very long time ago, a group of early humans learned to wait by a fire together and trust that what was cooking would still be there when it was finally done.